Okay, so in the last video, we went through how to figure out if you have constructive or destructive interference or something in between when we've got sound coming from two different sound sources. And those two different sound sources are playing the exact same frequency. So we've got this mess here that's on the screen. And the way to figure this out is to figure out the distance from each one of these sound sources, figure out the difference in those two distances. That's going to be our delta PL. Whoops. That's going to be our delta PL. And then if we have the wavelength of the sound, lambda, we can figure out the value for X. And then we said if X is an integer, we've got constructive interference. If X is a half integer, and maybe I really should say half of an odd integer, then we have destructive interference. Basically what I mean here is that, well, if we've got X is equal to 0.5 or 1.5 or 2.5 or 3.5, you get the picture, so on and so forth. Then we've got destructive interference. If X were 0, 1, 2, 3, 4, so on and so forth, then we would have constructive interference. At some point, I'm going to throw this computer right out the window. The streaks come from screen malfunction of my computer. So that's pretty awesome. All right. So let's see here. Let's try and do maybe an example problem again. We did this one already in the last video. But this one that I've got here is actually one for you to attempt first. It says that we have two identical speakers. They're emitting a constant tone that has a wavelength of 0.5 meters. Speaker A is located to the left of speaker B. So basically the same setup as we had on the previous figures, except now we're going to move our little guy around. It says that which of the following locations would complete destructive interference occur? Choice A, B, C, or D. At this point, I would like you to pause the video, see if you can figure out which one it is, and then see if you're right. So pause. All right, let's see what the right answer is. Let's see what the right answer is. There we go. It's actually choice B. So let's see if we can identify why that is. So first off, we're given the wavelength. We're told that lambda is equal to 0.5 meters. And we're given these four different options. So for each one of these four different options, we basically need to figure out what our delta PL is and see if we end up with what? An X that's equal to 1/2 or 1.5 or 2.5 or 3.5, so on and so forth, that would give us destructive interference. Okay, so let's see. For choice A, our delta PL for choice A is going to be the distance 3 meters. That's the distance from the speaker B to our person, minus the distance from speaker A to our person. That's 3 minus 2.5. This is 0.85 meters. Okay. Well, delta PL is equal to X lambda. 0.85 meters is equal to X times 0.5 meters. X then would be equal to 0.85 divided by 0.5. That looks like, what is that? That's like, maybe I should have figured this out beforehand, but I think that's something like 1.7 or something. It sure isn't 1.5. I know that much. So, so we don't have a condition for destructive interference here. If we wanted destructive interference, it would have to be 0.5 or 1.5, 2.5, so on and so forth. So yeah, choice A doesn't work. Let's think about choice B then. Okay, choice B. Well, I've given us the answer. We know that it's right, but let's take a look at it. Our distance away from speaker B is 2.5 meters. Our distance away from speaker A is 3.75 meters. So our difference in path lengths there, we'll take the big one minus the small one, is 1.25 meters. Okay. And then we've got what? Delta PL is equal to X lambda. 1.25 meters is equal to X times, let's see, our wavelength is 0.5. If I divide 1.25 by 0.5, I get what? What do I get? I get 2.5. Okay. And then I think about my condition for destructive interference. My condition for destructive interference says that what? That this is destructive, not a B, destructive, if X equals 0.5, 1.5, 2.5, 2.5, 3.5, so on and so forth. And yeah, so I've got 2.5 for choice B. So as a result, choice B does give me destructive interference. I should hear no noise at that location. I want to look at, so we've got our answer. We're going to assume that there's only one correct answer. Frankly, my throat's starting to hurt a little bit, so I'm gonna not do D. Let's go ahead and do C though, and see what C is. So choice C here. Choice C says that I'm 2.5 meters away from A and 1 meter away from B. My difference in path lengths, 2.5 meters minus 1 meter is 1.5 meters. 1.5 meters. And so if I think about my delta PL is equal to X lambda equation, 1.5 meters. 1.5 meters is equal to X times 0.5 meters. Let's see, 1.5 divided by 0.5, that would give me an X value of 3. X is equal to 3. And so that would mean that the X is an integer in my equation. And if I've got X as an integer, when I go through and I do the solution, that means that I have constructive interference and that I would hear a loud noise. So C is actually a point of constructive interference. So that's an interesting point as well. You know, for this particular problem, we were looking for the point that provides destructive interference. So that's choice B. All right, that does it for this one.